Hi everyone, in this video we'll be looking at the group 18 elements, otherwise known as the noble gases. You are probably familiar with the noble gases because we have discussed that in chemical bonding before, but today we'll focus on two key things. Number one, to recap why noble gases are unreactive, and also to understand some of the uses and applications of noble gases. The noble gases, by the word gas, suggest that they have a low boiling point, and that implies that little energy is required to overcome the forces of attraction between the atoms. In addition, they are insoluble in water. They are also colorless gases and odorless gases. So you can see here that it seems like the little glass ampoules may not contain anything, but they are actually a collection of noble gases. Let's look at some data first. What trends do you notice in terms of the melting point, boiling point, density, and atomic radius? Pause the video and think about it first. Firstly, we see that the melting and boiling point increases down the group. This suggests that the attractive forces becomes stronger and more energy is required to overcome the forces of attraction. Secondly, we also see that the density increases down the group because as the atom gets larger, there is more protons, more neutrons, the nucleus gets heavier. So the mass per unit volume will increase. Finally, you can also see that the atomic radius increases down the group, and that is because the atomic radius is related to the size of the atom. So going down the group, you have more and more electron shells. With every period, you have one more electron shell, and that makes the atom bigger. So let's do a very quick recap. Use the electronic structures to explain why noble gases are unreactive. Pause the video and think through before I go through the answer with you. So the keyword here is to mention that noble gases have a fully filled valence shell of electrons. And this gives them a stable electronic configuration, and they do not gain, lose, or share electrons with other elements. So a fully filled valence shell for helium would mean 2 electrons because the first electron shell can only hold 2 electrons. For the rest, you can have 8 electrons in the outermost shell. So since they do not bond with other elements, they tend to be alone. We call that monoatomic. So they exist as individual atoms. Let's look at some properties and uses of some of these gases. You are probably familiar with helium because we use that to fill your party balloons. I came across this video where a backpacker tries to use a large balloon filled with helium to lighten the load on his shoulder. Let's take a look.
Helium as a backpacking assist. Oh, that is perfect. Look at that. It's the opposite of putting on a backpack normally. Oh my gosh, that's a dream. This is essential kit for backpacking, I think. It's almost too light. I gotta pull it down. You wanna get something out of your pack, you just, it's right there. Oh, as long as it doesn't blow away. Uh-oh.
Okay, so I want you to think about this. Is this a gimmick or is this true? How much helium do you actually need to lighten the load of your backpack? So let's say if your backpack is 7 or 8 kilograms, how much helium would you require to actually feel a difference in the weight, or to make it feel like there's nothing? Can go and find out and do some calculations and think about this. Is this a practical solution or not? But I thought it was quite an interesting idea. Helium is also used to fill weather balloons. Weather balloons can be used to lift electronic devices up to high up in altitude to do some sort of measurements. So let's take a look at this video. As the balloon rises higher and higher, due to the lower pressure, the balloon will actually expand. And you'll come to a point where it will burst, and then that is where it will fall back to Earth. There are also many other applications of helium beyond just balloons. Because helium has a very low melting and boiling point, it is able to reach very low temperatures. These low temperatures enable it to be used as a coolant for nuclear reactors or to make superconductors work, such as those in magnetic levitation trains, as well as the MRI machines that is used in hospitals. So because of its very useful applications, we need to conserve helium because helium is a finite resource. We don't want it to run out eventually one day. Let's talk about neon, okay, which is the next member in the noble gases. I came across this person on social media, and her name is Megan. She actually started a business making neon signs. Let's take a look.
I quit my corporate job to be Singapore's only neon artist. It's unconventional, but I took a leap of faith. Since starting Neon, one of my goals has been to make text works. Today, to celebrate my journey as an artist, I decided that I would make my artist name with a twist. This sign is filled with neon and starts off red. But did you know that you can make a color-changing neon sign? With the right temperature and a drop of mercury, the sign can change into blue and create a gradient effect.
So there is a bit of chemistry knowledge that comes together with art as well. Neon is used to make advertisement lights, and that's because when you pass a current through it, it emits light. To change the color of the neon sign, let's say if you want yellow, green, or blue, okay, we can use other elements or other noble gases in fact, or what we call phosphor coatings. Let's take a look at one of the signs she made for Potato Corner, which is at Ngee Poly, if I'm not wrong.
Check it out, check it, check it out, check it, check it, check it out, check it. Hey, Greg and a CE, call me hip hop junkie. Straight to your dome piece like Brass Monkey. All I wanna know, do you wanna get funky?
Alright, so neon is used to make advertisement lights. What about argon? Argon has two uses. The first is to fill electric light bulbs. Light bulbs work when you pass electricity through a tungsten filament, and because of that, it glows, and the glow is what lights up the room. Okay, nowadays LEDs work by a different method. Okay, the drawback with tungsten light bulbs is that they are not very efficient, and a lot of the energy is actually converted to heat. So in the light bulb, they actually fill it with argon because argon is an inert gas. So it prevents the tungsten from undergoing oxidation because it will react with oxygen. Once the tungsten reacts with oxygen, it becomes tungsten oxide, which is an ionic compound. And you know that ionic compounds, they do not conduct electricity in the solid state. So it's no longer a metal. It doesn't allow current to pass through. So let's take a look at this experiment over here.
Now normally when you break the bulb of an incandescent light bulb, this is what happens when you turn it on.
Whoa, that actually lit for a while.
The filament that's in there quickly oxidizes and burns completely through, so it can't light up anymore. Okay, now I'm gonna carefully break this. Whoa. Okay, here's our cup of liquid nitrogen. Okay, let's turn it on. 3, 2, 1. Whoa, it turns on still.
Okay, so nitrogen is also inert. So when we put it into liquid nitrogen, it is able to turn on. But once it's exposed to oxygen, that's it. Okay, at a high temperature, the tungsten reacts with oxygen. The second application of argon is in the manufacture of steel. You have learned that steel is an alloy, a mixture of iron and carbon. When we want to turn steel into stainless steel or for other purposes, we need to reduce the amount of carbon content. And this is done using this method called AOD, which is argon-oxygen decarburization, in which argon is mixed with oxygen and blown through the molten steel. The oxygen reacts with carbon to form carbon dioxide, and the carbon dioxide will kind of escape. That decreases the carbon content. So before we move on, can you recall the applications of each of these noble gases? What is helium used for? What is neon used for? And what is argon used for? Alright, here's the summary. Okay, make sure you are aware of that. So let's review our learning objectives for this section. Number 1, we talked about why noble gases are unreactive, and that's due to their fully filled valence shell. And we have also covered the uses of the noble gases. Alright, so that's all for this video. I'll see you in class.